Gauthier. As mentioned, I'm the VP of Operating Tools and Technologies at Unity, and I'm also in charge of the studio here in Montreal. We're getting bigger and bigger by the day. So if I talk a bit about my career, I started during my university study at Polytechnic in engineering, and started a company named Kaydara with a few friends. What we were doing is a software called MotionBuilder, and it was doing motion capture. If you don't know what that is, it is when you're dressed in the black suit with all the little dots, and then you end up being recorded, and you record the human motion, the face, and you're able to actually animate characters in real time. So did that for a long time, and we ended up being used in a lot of things, in movies, in content creation, and in gaming. So the Matrix and Avatar and essentially Tintin and all kinds of movies now that are created using this because they combine 3D, real-time, and usage of this. And then from that I moved to Autodesk because we got acquired, and Autodesk is doing a lot of 3D applications to do design of buildings, design of objects, and also tools that are doing film and 3D in film. And finally ended up going to do cloud for a while because that looked really interesting. And about 6.5 years ago, I approached Unity and I started the Montreal office here. So for those of you who don't know what Unity is, Unity is creating game technologies, a game engine, and everything that needs to be surrounded around it in order to do what you're trying to do. So in order to create a game, what you do, you need an engine that runs the game and the interactive experience, but you also need an editor where you can put content, you can put code, and then integrating this, you generate an app, and an app is a game. So that's what Unity is doing, and Unity is now the most used game engine in the industry, and by quite a margin, and there's a reason for that. So a bit of history. So how did that start? It's a few guys out of university wanted to do a game in Copenhagen, and they started coding their version of their game, but in order to do their game, they created an editor. And weirdly, they chose, 12 years ago, they chose Mac. And that was kind of a weird choice for that industry, because not only there weren't that many games on Mac, but having to create the interface on that, it was kind of a weird choice. But it happened to be really kind of an interesting one because of this. So what happened is, at that time then, the iPhone started booming. And because the editor was working on a Mac, and the engine was working on a Mac, ported to iPhone, then it was the first 3D game engine on the iPhone. And as you know, that worked out well. So there's many reasons why it changed everything. So it changed everything because in the past when you were doing games, you needed to have a publisher. And you would print DVDs, and you would send that to Walmart. So not everybody can do that. With the iPhone store, what you have is quite a different way of distributing, because you can self-publish. You can send your apps, and your apps can be discovered. And the business model of Unity at that moment was free for everybody. And if you start making over $200,000, then you pay for your license of editor. So it wasn't a crazy at moment where game engines weren't available for everybody. It boomed. So we started with Android. After that, started iPhone, then did Android, then did Xbox, and now 28 platforms. So you create your application, you write your code in C#, you publish, and then it runs on the smart TV or an iPhone or something like this. So that explains why now it's the most used game engine. It's because it gives you reach and it gives you ways to publish apps everywhere with the same kind of code base. A bit still on the history of Unity, then working with people doing great games, you're creating those games, and then you put them on the App Store, and then you die because you don't have any money, your game is not discovered, so it's quite a difficult story. So, and people tend to focus a lot on the create part because they love the game, love the experience, and they forget that, yeah, it's free to play. How do I get my customers? How do I get the referrals? How do I do that? So Unity bought and created services on both the operate side, which is if my game wants to run, needs to run, and talks to the other parts. But also, how do I sell items? How do I have ads if I'm free to play? So how do I set it up so that it works? So we provide services around all of those things. So these are, some titles, some games that that are built in Unity. In fact, there's quite a lot of them. In fact, there's really quite a lot of them. So if you look at what we're doing, there's about 3 billion devices. We have 33 billion installs, and if you look at it, it's about 1,000 install every second of a Unity-based game. So it's quite a lot of reach, and the reason why it's important for us is that it kind of gives us an insight into what's happening in the market. Because I talk about game quite a lot, but it's actually really changing because the game technologies now are starting to be used elsewhere. And that's what I'll talk about. So why is that happening? So one natural extension would be film, because film has been in 3D forever. In fact, they were the ones that pushed it quite a further at the beginning. And you know for a fact because they're being used, and you've seen visual effects now. If you don't have visual effects in a film, you're kind of bored. It's all over the place. It's been integrated forever. The visual quality is there forever. But the problem is it takes forever also to create one frame. One frame of film can take up to a day to render, especially when there's fur and all kinds of special effects. And we started using real-time 3D in virtual production. So what they do is you'll have a 3D scene and you'll walk with virtual cameras and start filming the virtual set, essentially, and you would do filmmaking in 3D like you would do filmmaking in the real life, except that what you're filming doesn't exist. And so we're seeing that with The Lion King using Unity. The other change in there is I would like that to play. It's not playing. Let me check if that movie is available. Yeah, we'll do it this way. So what you see here is the visual quality that you have on the screen is actually what you see in interactive mode, so you're able to change things as part of what you're doing interactively. So if you want to move the fire and you do this, you can then move characters around, and by having the interactive and the visual quality that you see, then you can actually do final frame render out of the engine. And this changes the whole workflow because the time you have to wait for those things to be true was really a long time in the past. So the other thing we're seeing is the coming of the virtual reality device. We've seen this, people would say, hey, we'll change gaming, it's incredible. But the thing is, it's generally a showpiece in your basement because you use 3 times the games, and then not so many virtual reality devices are being used, but if you look at the industrial sector, it's used quite thoroughly, quite a lot. The other part is the augmented reality part. So augmented reality now is in mobile, so it's essentially, and you've all seen Pokemon Go, and so where you get a combination of the real life and what you see through your device. But the thing is, we're seeing the augmented reality devices being developed more and more. And what it does, that pulls the industrial part of the business to game engines. So we started to work with them and do things like this. So we're working with Volvo, and we're starting to integrate virtual reality or augmented reality inside the dash, inside of the windshield of your car. So essentially, you get additional information projected. So when you drive, you don't have to think about the information. It's presented to you in a way that is ingestible for you. Another example is what we call ray tracing. If you're familiar with ray tracing, this is a way film does the visual quality, the reflections, everything that you need to see. So ray tracing now is in real time. And it's being developed more and more. Companies like NVIDIA and the hardware manufacturers are integrating those chips inside the hardware today. So what it means, and in this case, I don't have the video with me, but I invite you to go to the web and have a look. If you look Unity and real-time ray tracing, you can see this. What we did is we filmed a real car in a real studio. And then we created a whole version digital. And we did a video, and we were cutting from one to the other and asking people to know when one was real and the other one was real. And most people cannot make the difference. And it's interesting, we even had both cars, one next to the other in the same image, and people will not know which one is the real one. So another application for those things is when you want to try to visualize your design. So you're an automotive maker, you're using a design application, you're creating a car, you're modeling this, and you want to see what it looks like in the environment, not just in your design app. So what we're seeing here is an actual application. It's a real time, it's not rendered, where you can then start modifying the environment, project the elements, and see how your car would look like in the real world, with the lighting, reflecting on it, seeing how it would fit. And this is running, on a PC with a virtual devices device. So we call it AEC, generally architecture, engineering, construction. So one thing we're seeing there is a designer, somebody designs a building and designs an object. For one person designing an object, what you want to be able to do after that is visualize that design, as I mentioned, in context. Great. But then, if you look at the lifespan of a digital piece of information, when you design a building, it gets built. What it means is, there's hundreds of construction workers that will need to access the design information in order to build. Right now they're using plans, but there's all kinds of ways of using that information in different ways. So from the design, you try to sell it. Once you sell it, you build it. While you build it, you need that information. And then the building gets built, and after that, the building exists. How do you maintain it? Do you need access to that information? So these are cases where you're trying to sell, pitch the project, but then as you're playing with the models, we have things that are, people integrate more and more the design information and gets published to an interactive application. So as you're modifying elements in the design, they get pushed into applications, get pushed into final application, and then you can start wanting to anchoring those designs inside the real world. So the combination of what the digital life looks like once integrated. And we continue on this other one, which is when you're starting to build it. So anchoring, trying to make sure that you take the design that is anchored, move that into the real world, look at the construction site and see the difference between what is being built and the plans that are present. So the combination of the visualization, the plan, the real life, allows workers, allows people to actually make changes, and then they can annotate, say, hey, this is broken, and it should get sent back to whoever, either the design team to adjust or the studio to then adjust. All right, So that's interesting. This is happening today. The consequence of that is not a small thing. What we're seeing, because we're working with all manufacturers directly. Hello, okay. Because we're working with all manufacturers directly, we see that they're evolving those technologies. So we see all kinds of research. Glasses, even contact lens, to start creating and experiencing what we're trying to see. And the glasses are ugly right now, but if you look at what Apple did with the watch and something, those elements are starting to become devices that will be integrated in your lifestyle because they need to be stylish, they need to mind the fact that you're wearing them. But if you look at the outcome of that, it means that there's a device between you and your reality. And right now we're spending a lot of time looking at our phone, but then the information will be integrated inside the view, you'll view the world, and you have additional information around you. And this is not a maybe, this is a absolute. We're seeing the rhythm and the interest that those manufacturers have toward this. This will change really, really a lot of things. So what does that mean? It means that what was 2D, an app, will become 3D because this thing needs to be integrated inside your environment. If I'm looking at something, like looking at a chair, if I'm looking at my Facebook information, they will exist in conjunction with the real world. So you must mind this. The second part is this. When you're isolated in each of those things, your own experience, when you have a shared experience, it needs to be run by both sides. If I'm in front of you, you have an Android, I have an iPhone, glasses, you have an Android contact lens, and we're looking at something, it means that that thing needs to be conjoint. So where's the data? The data needs to exist globally. Where's my code running? In my app and globally, because that experience needs to exist for both of us. And we need ways to communicate around this. We're looking also, because you're in the context, in the content, it pushes us to create more adaptive content that is interactive or reacts to the people that are there. So obviously we see that in games, because games is interactive content, but if you look at film and Netflix, they're starting to do, episodes where you choose what's happening, but there's a relationship between the media and the objects that are inside it. So you'll see more and more of the interactivity coming into the predetermined media. The other aspect of it is about when you try to integrate inside the real world, you have to know what the real world is. So if I want to appear on a table, I need to know that it's a table. So having AI, machine learning, identify those things, try to understand what the world is, because if you look at those devices, they're scanning. They're actually scanning images, depth, and they're trying to figure out what they're seeing. And they use cloud services to do that. And what I'm saying is these things are happening today. It's not science fiction. So as you identify humans, objects, there's many things you can do with that. You can use that to scan, so you can grab objects that are there, get them inside your app. You can scan the movement of people around you, and then use those things to create movies, create animations, create elements. So this intelligence is there. And finally, it's integrated in your life. So it means that there's something between you and your world. That something is a device, an app, that can scan, view, and understand what's there, but also it will give you the information in a way that is kind of easily ingestible for us. Because your instincts are all at work at that moment, because it's not reading, it's actually experienced the same way you would experience the real world. So it's really a great responsibility in many ways. It's scary, and it's also fantastic. It depends on what we do with it. But the fact is, this is what is happening right now. So I would say, learn to understand, master those technologies. Please take the time. There's plenty of information around this. And learn to use them to your advantage for you and people around you, but also for your generation and for what needs to happen in the future. We have a responsibility of having those apps, those devices, do the right thing for us, but it's also a lot of opportunities. Thank you.